Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, here we go. We're going to answer the last two parts. We already got the answer to part A. That was 5.2 centimeters. We completed that yesterday. But for today, we've got to check and make sure that we've got all these answers correct. So let's just go from left to right. First, glass 1 is one complete cylinder with a radius of 2.5 centimeters and a height of 6. So to complete this problem, we should use our calculator, and we need to figure out what is 2.5 squared. So 2.5 squared is 6.25. So we're going to take pi and multiply it times 6.25, and then multiply that again times the height, which is 6. So you can multiply that in any order you want. I'm just going to go ahead and take this times 6, which is going to be 37.5. 37.5 times pi, which is 3.14. And we are going to get ourselves a volume of how many cubic centimeters? Let's multiply times pi. 3.14 is 117.75. So 117.75 cubic centimeters. I will draw a box around that. And maybe I should move all this over a little bit so we have room for this guy. Okay, this one's going to require a little bit more room. Change my color. All right, so we know that this is going to be pi times 3 squared times 3. So in essence, it's 3 squared is 9 times 3 is 27. So this is going to be 27 times pi. And let's figure out what that is. So for the cylinder part, 27 times pi, 27 times, oh, no, we're doing 3.14, aren't we? Is 84.78. 84.78 cubic centimeters. And now for the circle part, we're going to take 2/3 of pi times 27. So what's 2/3 of 27? Isn't that 18? So this is going to be 18 pi. So the hemisphere portion is going to be whatever 18 times pi is. So 18 times pi, 3.14, is 56.52. 56.52 centimeters cubed. So when we add those together, our total sum is what? 141.3. 141.3 cubic centimeters for our volume for glass 2. Now, this information is really important information for us when we get to the third part, or part C. Because remember what I said yesterday, you're going to pour off half of the water. But the cylinder portion on the top is more than the hemisphere portion on the top. So if you take away half of 141.3, aren't you pouring off like 70, 71, somewhere around there, which means you're going to pour off a portion of the cylinder, but not all of it. So there'll be some part of the cylinder left over. And then we have to use that to measure the height. But we'll get to that when we get to part 3. All right, so let's get back to our cone-shaped cup or glass. What do we have here? 1/3 times pi times 3 squared times 5.2. So I believe that this 1/3, if I multiply that times 9, that's going to be 3, right? So this is going to be pi times 3 times 5.2. And what is 3 times 5.2? 3 times 5.2, that's going to be 15.6. So 15.6 times pi, what is the volume of glass 3? Let's check that out. That times 3.14 is 48. I think I'm going to call that 48.98. I guess 48.98. 48.98. Some of you might have actually rounded that up to 9. I'm going to go ahead and do that. 49. Let's just call this 49. That is so close. 49 cubic centimeters. All right, so that completes part B. We've got our volume. Now, which one has the most volume? Class 2. Which one has the least volume? Class 3. Didn't ask us for that, but that's what it is. All right, so I'm going to take this piece of information right here and work my magic. I'm going to copy that, and I'm going to paste it over into here because this is really important information for us to have. All right, so when filled, this glass has 141.3 cubic centimeters, but we're going to pour off half of that water. So what do we have here? Let me change my color to red so we can see it. So what is half of 141.3? 141.3, half of that is 70.65. So we're going to take our volume is going to be 70.65 cubic centimeters after the half has been poured off. And we know that the hemisphere part holds 56.52 cubic centimeters. So how much extra is in here? So if I were to take 56.52 and subtract that from 70.65, that would tell me the height of the water that is in this section of the cup. Because remember, 70.65 was poured off, so this is all empty space here, but this is water in here. So how much of that is water? Let's go ahead and do that subtraction and take that minus 56.52, and we're going to get 14.13. So the volume of this little mini cylinder right there is 14.13 cubic centimeters. All right, so keep in mind, we now know the volume of a cylinder. This shape in here is a portion of a cylinder, but it's a cylinder on its own because it has a base area. In fact, it's got two base areas, right? If you want to consider that, with the same area, base area as the original cylinder. So if I take the formula for a cylinder, and I know the volume is 14.13 cubic centimeters, and I know that the base area, what was the base area that we had found before? The base area of that portion of the cylinder was pi r squared was, oh, I guess I never figured it out before, did I? That was 9 times pi. So let's figure out what 9 times pi is. Because remember, let me erase this. This is starting to bug me a little bit. Just put this line here. Boom, 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 boom. All right. So what is the base area of this? That is, the radius is 3. So 3 squared is 9 times pi. 9 times pi is 28.26. So 28.26 times the height. The height is what we're trying to figure out here, correct? Because we want to know what is the height of the water. We know this portion from here to here is 3 centimeters. What is this portion in here? And don't guess it. Don't say, oh, it looks like it might be 1 centimeter. No, don't do that. I didn't necessarily draw that to scale. We have to solve this for h. Once we know what h is, we'll know what the height is of this section right there. So we're going to have to divide each side by 28.26. 28.26. And do you recognize the relationship here between those two numbers? The height of this section of that cylinder is going to be 14.13 divided by 28.26. It is 0.5. So we know this is 0.5 centimeters. So what is the total height of that water that still remains in the cup? It has to be 3.5 centimeters, which means 2.5 centimeters was poured off. So if you wanted to check it, which I know you do because you love checking things so much, let's figure out if everything here balances out. Let's take the remainder of this empty cup. We know that the base area is 28.26. That's the base area, and the height we think is 2.5. So let's multiply 28.26 times 2.5, and what do we get? We get 70.65. Wasn't that the amount that was poured off? Yes, it is. So the amount that was poured off is this empty space, which we have just determined was 70.65 cubic centimeters. So we poured off half, meaning we poured off 2.5 centimeters worth of water, which left you with 0.5 here, plus the additional 3 that never got poured off from the half sphere or the hemisphere. So this concludes our glasses task, where we determined that the answer for part C is there is 3.5 centimeters of water remaining in the cup. All right. If you got that on your own, you are genius, awesome, good job. If you needed the help with your parents, but you were able to figure it out, you are utilizing your resources and you are awesome, and that is what you need to do to be successful in life. If it was a struggle for you, keep working at it. You know, these are the types of problems that you're going to become expert at if you pursue math, if you continue to work hard in all of your math classes. All right, so I believe today is a day where we're going to work on a rolled oats task, and so I better get started working on that. I think you're going to find that much easier. All right, take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.